Hello there, Mr. Sutton here, bringing you the IM3 Honors 4.2 Extra Practice number 6 solutions on solving by square rooting and kind of sort of completing the square. This one has a puzzle associated with it, so let's take a look at that. So here's the puzzle that goes with this extra practice. We're trying to solve this riddle, which is what do you get when you cross a cooking utensil with a mathematical formula? So the idea here is we've got 15 equations that we need to solve. Once you find the answer down below, you just have to find that answer here and cross off the letter above it, and whatever's left over at the end is going to be the solution to this puzzle. So let's get going. So here's our opening problem. On this one, we can actually solve by square rooting right off the bat, since this squared stuff is all alone on the left. So square root of the left side is just x minus 4. We just undo the square root, the square there. And then we have a plus or minus. We have to remember plus or minus when we square root equations. Plus or minus 5 over on the right side. To get x by itself for real, we have to add 4 to the other side. So we have 4 plus or minus 5. And then to match one of the answer choices, we have to simplify it further. 4 plus 5 is going to be 9. 4 minus 5 is going to be negative 1. So 9 and negative 1. Where do I see that down here? Right there. So we're going to cross off the letter H since that's above there. For this second problem, before I can square root anything, I want to divide by this 5 so that that doesn't get caught inside the square root. So dividing that over to the other side, we've got x plus 7 squared equals 1. Now I can square root both sides, so that gives me x plus 7 on the left, and I'm going to do plus or minus square root of 1, which is also 1, over on the right. To get x by itself, we subtract 7, so we have negative 7 plus or minus 1. And to fully get the answer, we have to simplify this a bit. Negative 7 plus 1 is going to be negative 6, and then negative 7 minus 1, we've got negative 8. Negative 6 and negative 8, I see that over here toward the front, so we'll cross off that C. For number 3, we're going to start by getting rid of the 3 that's being multiplied out here in front. So dividing both sides by that, we have x minus 2 quantity squared equals 12. And now I'm going to square root both sides. So we got x minus 2 on the left, and plus or minus the square root of 12 on the right. Now the square root of 12 can be split up into radical 4, which is a perfect square, times radical 3. So let me add 2 over to the right side to get x by itself. And while I'm doing that, let me finish simplifying this. So that's going to be plus or minus 2 radical 3. I can't go any further with simplifying, so that's just going to be my answer. And it looks like I've got that. It's kind of hard to tell because these are all written sideways, but it looks like it's right here, 2 plus or minus 2 radical 3. So cross off the D. For number 4, this is where things start getting a little bit trickier. There's no squared thing that I can easily isolate on the left side so far. I mean, if I try to get this x squared by itself, I've got this x to mess around with. But what I can do, the left side actually is a perfect square trinomial. If you were to factor this, things that go into 25 add up to negative 10. That would be negative 5 and negative 5. So this is actually x minus 5 quantity squared equals 9. Now I can just square root both sides because this is something squared equals a number situation. So we have x minus 5 on the left and the square root of 9 on the right, plus or minus that, so plus or minus 3. Adding 5 over there, I have x equals 5 plus or minus 3. And now let me actually get some numbers out of this. 5 plus 3 is 8. 5 minus 3 is 2. So 8 and 2. That's the very first thing in my list of answers, so cross off the S. For number 5, this one's actually not so bad if you were paying attention on number 4. They gave us a perfect square trinomial in that problem. In this one, they're doing it again. All this stuff on the left side, this is really just x minus 3 quantity squared, which if you don't believe me, multiply these together and double it, and you do get negative 6x, so that works out. So now I can just go ahead and square root both sides again. So we have x minus 3, and this is going to be plus or minus 7 on the right. Add the 3 to get x by itself. 3 plus 7 gives us 10. 3 minus 7 gives us negative 4. 10 and negative 4, that's right here under the L, so cross that off. On this next problem, this time on the left side, we have another perfect square trinomial. This one is going to be x plus 1 quantity squared. So we're kind of seeing a pattern here with the types of problems they're throwing at us. And then if I square root both sides for this, I've got x plus 1 equals the square root of 64, so plus or minus 8. Subtracting 1 from both sides, we have negative 1 plus 8, which is 7, and negative 1 minus 8, which is negative 9. 7 and negative 9, where is that? That's at the other end, all the way over there, so that's h that we're losing. All right, we're on to number 7, and the perfect square trinomial fun is continuing over here on the left side. All this stuff on the left side now, if we square root, we've got x, we've got 9, we've got a negative, x minus 9 quantity squared. Multiply these together and double it. That is going to be negative 18x in the middle if I do that. So this is some good factoring here. Square rooting both sides, we have x minus 9 on the left, and the square root of 24 plus or minus that on the right. I can split that up into 4 and 6 because 4 is a perfect square. So getting x by itself, I'm going to add 9 over there. I'm also going to square root this 4, so plus or minus 2 radical 6. 9 plus or minus 2 radical 6, where's that? That's this second item here, so cross off the t. For this problem, we have another perfect square trinomial on the left side. This is going to be x plus 6 quantity squared. Square root both sides, we've got x plus 6 equals square root of 75 plus or minus. That can get split up into 25 and 3. So subtracting 6 to get x by itself, I've got negative 6 plus or minus square root of 25 is 5 radical 3. And then negative 6 plus or minus 5 radical 3. I see that right here under the e, so there goes e. For number 9, we're going back to having just a squared thing on the left side. So we should be a little bit suspicious because it looks like they're giving us an easier problem, but we've got a fraction in there, so that's why we're going back to this level here. So I can square root both sides to start this thing. Starting, it's not so bad. So that's going to be x minus 1/2 on the left, and plus or minus square root of 1, so plus or minus 1 on the right. And of course, we'll add the 1/2 over there to get x by itself. But now we have to simplify this. So I've got 1/2 plus 1. That's 1 over 2 plus 2 over 2, which is 3 over 2. And now I have 1 over 2 minus 2 over 2, which is negative 1 over 2. So 3/2 and negative 1/2. There it is right there under the I, so cross that off. Number 10 looks all sorts of crazy. They're just busting out these fractions left and right now. But we can start this the same way we did the last one by square rooting both sides. So I'm going to have x minus 3/2 on the left and the square root of 7 over 4 plus or minus that on the right side. Now with a fraction, when you're square rooting, you do the numerator and denominator separately. Can't really do anything with the square root of 7, but the square root of 4 is 2. So this is plus or minus radical 7 over 2. And now I'm going to add the 3/2 to get it over to the right side so that the x is by itself. When I do that, since I have a common denominator of 2, I can actually write this as one big numerator of 3 plus or minus radical 7 all over 2. And now if I can find that down here, it looks like I've got that right here under the n, so there we go. 11 is kind of like the last one in a lot of ways. So we already have some squared stuff by itself, so we can actually just square root both sides right off the bat. And then I'll have a plus or minus, let's see, well, we got the x plus 5 over 2 on the left, and then we'll have a plus or minus square root of all this stuff on the right. Can't really do much with the square root of 15, so I'm just going to leave that as radical 15 in the numerator. In the denominator, though, the square root of 4 is 2, so plus or minus root 15 over 2. And now to get x truly alone, I'm going to subtract 5 over 2 from both sides. Since I already have a common denominator of 2 over on the right side, I can put the 5 and the plus or minus radical 15 all in one big numerator. Only if I move this over, it's going to be a negative 5 up there with the radical 15. And that's going to do it for this one. Let me see if I can find this down below. Looks like it's right here under A, so cross that off. For number 12, this problem actually looks deceptively simple, but it is a little bit tricky once we get into it. So to get x squared alone, first we have to divide by 2. And now I've just got x squared, so I can square root both sides. So that'll give me x equals plus or minus radical 5 over 2, this whole thing. Now, I'm not allowed to just leave this as a fraction inside a radical, not if I want this fully simplified, not if I want to match something down here. So I'm going to start by splitting this up into radical 5 over radical 2. I'm allowed to do that. It's the moving out rule of radicals. And then I can't have a radical in the denominator, so I'm going to multiply this by root 2 over itself, just a fancy form of 1, and that'll give me radical 10 over just plain old 2. So plus or minus that, and now I can match that with something down below. Right here, under the I, there we go. For number 13, I have squared things all by themselves, so let me go ahead and take the square root of both sides. That leaves me with just x minus 1/2 on the left, and on the right, I'm going to write this for now as plus or minus square root of 3 over 2. And then I can split that square root up into radical 3 over radical 2. No point in keeping inside a radical any longer than I need to. I do need to simplify this at some point. I could wait or do it now. I'm actually going to take care of it now because if I add this 1/2 over to the right side, I'm not going to have common denominators yet. So let me simplify this and see if I can get this taken care of right away. So I'll multiply this by radical 2 over radical 2. That'll give me radical 6 over just plain old 2. And now, if I add this 1/2 over to the right side, I have a common denominator of 2. So I can write this as 1 plus or minus radical 6 all over 2. Now that's going to match up with something down here, hopefully. Over here on the right end, that gets rid of the x. So we're xing out the x, and we're moving on. For this next one, in a lot of ways, kind of similar to the last question, I can square root right away since squared stuff is alone. So we have x minus 3 over 5 with no square. And then on the right side, plus or minus the square root of 4 over 5. Now the square root of 4 is 2, so I can write this as 2 over radical 5. Can't do anything about the 5 right away. However, since I don't want that radical in the denominator, let me multiply by radical 5 over itself. So that gives me plus or minus 2 radical 5 over 5 over there. And now to get x by itself, I'm going to add the 3/5 over to the right side. So that's a common denominator. I can have one big fraction over 5. And in the numerator, it's just going to be positive 3 plus or minus 2 radical 5. So let's see if I can match that with something down here. Looks like A is the one I need, so let me cross that off. So now we're on to the final problem here, final boss battle. So right away, I need to get rid of that 3 if I'm going to square root both sides. So let me divide by 3. That's 1/3 then on the right side. And now if I square root both sides, I've got x plus 7 over 3 equals square root of 1 over square root of 3. And the square root of 1 is just 1, so I can write this as plus or minus 1 over radical 3. And let me take care of the radical right away, because I'm going to need to do that if I want to combine like terms anyway. So multiplying by root 3 over itself, I now have radical 3 over 3 on the right side. And now I can just subtract that 7/3 to get it over there. So that'll be negative 7 plus or minus radical 3 all over my common denominator of 3. And it looks like I've got that, let's see, where is it? It's got to be somewhere. This looks kind of similar with the negative 7, but it's a radical 6, not a radical 3. So let me keep looking. There it is, under the S. So let's cross that off. Now we can move on to actually solving the puzzle. All right, let's see what letters are left over. So we have an A, we have a P-O-T, P-I. So if I'm parsing this out, I think my first word is just the letter A. So what do you get when you cross a cooking utensil with a mathematical formula? A, and then P-O-T, that's pot. And then pi, that's all that's left. That's actually a word. That's the name for the number pi. So a pot pie. Oh, okay, because like a pie that you cook, and it's a cooking utensil and it's math, but pie, the symbol, yeah, you get it. All right, till next time, Mr. Sutton signing off.